Voyager 1 humanity's first steps into interstellar space. On September 5, 1977, NASA launched Voyager 1, a mission that would become one of humanity's most ambitious and enduring explorations. Built to study the outer planets of our solar system, Voyager 1 was launched just weeks after its twin, Voyager 2, during a rare planetary alignment that allowed for a grand tour of the outer planets. Originally intended for a 5-year mission, Voyager 1 has far exceeded expectations. More than 4 decades later, it continues to operate and send back data, traveling more than 14 billion miles from Earth, the farthest any human-made object has ever ventured. Equipped with some of the most advanced scientific instruments of its time, Voyager 1 quickly delivered groundbreaking data. It provided detailed observations of Jupiter's turbulent atmosphere, captured the first images of Saturn's rings and moons, and unveiled active volcanoes on Io, one of Jupiter's moons, an astonishing discovery at the time. But perhaps Voyager 1's greatest moment came in 2012, when it became the first spacecraft to cross the heliopause, the boundary where the Sun's influence ends and interstellar space begins. This marked the beginning of a new chapter in space exploration, humanity's entry into the space between stars. This milestone wasn't just symbolic. The spacecraft began to detect a dramatic drop in solar particles, a spike in galactic cosmic rays, and a shift in the surrounding magnetic field, clear indicators it had entered a new region of space, beyond our solar system. Voyager 1's journey into interstellar space opened a window into an environment that had only been theorized. And as it continues its mission, it sends back strange, sometimes inexplicable data. Physicist Dr. Michio Kaku has been among those intrigued by Voyager's ongoing mission. He recently pointed to anomalies in the data Voyager 1 is transmitting, patterns in the signals that don't match known plasma wave behavior or cosmic radiation. These unexplained signals have sparked interest and debate among astrophysicists. Could Voyager 1 be detecting phenomena we've never seen before? Some suggest the signals might relate to unknown structures or forces in interstellar space. Others raise more radical possibilities, such as the first indirect evidence of dark matter. Dark matter, believed to make up nearly a third of the universe's mass, has never been directly observed. Yet its gravitational influence is essential in explaining the behavior of galaxies. If Voyager 1 has encountered interactions involving dark matter, it would mark a groundbreaking moment in science. Of course, operating in interstellar space comes with enormous challenges. Voyager 1 has to survive extreme cold, high-energy radiation, and communicate across vast distances. To conserve power, NASA has shut down non-essential systems, allowing the spacecraft to prioritize data collection and transmission. Despite these limitations, Voyager 1 remains operational, a tribute to the ingenuity of its engineers and the durability of 1970s technology. Each bit of data it transmits continues to refine our understanding of the cosmos. Beyond its scientific achievements, Voyager 1 also carries the golden record, a time capsule of Earth's sounds, music, languages, and images. Meant to represent the diversity of life and culture on our planet, this record was designed to last for billions of years, offering a message of peace and curiosity to any who might find it. And perhaps most haunting of all is Voyager 1's ability to hear the universe. Its plasma wave instrument has recorded eerie, musical sounds created by interstellar plasma. These recordings, sometimes described as the sounds of space, are unlike anything heard before, haunting, beautiful, and mysterious. Yet recently, those sounds have taken on new characteristics, structured patterns that don't seem random. Patterns that may hint at something more. Voyager 1 signals from the unknown and the future of exploration. The strange patterns Voyager 1 has recorded in the depths of space are raising bold questions. Scientists are carefully analyzing the signals, subtle shifts in frequency, organized pulses, and repeating structures that don't quite fit into any known model of plasma physics or cosmic radiation. Some believe these anomalies may result from complex interactions between Voyager and the interstellar environment, perhaps particles or waves behaving in unexpected ways. Others wonder if the spacecraft is detecting previously unknown cosmic structures, possibly filaments or voids shaped by massive gravitational forces. But there are also more provocative ideas. A small but growing number of researchers are considering whether Voyager 1 could be intercepting signals of artificial origin, possibly emissions or communications from another intelligent source. While this theory is highly speculative and not widely accepted, the possibility has captured the imagination of scientists and the public alike. The idea may seem far-fetched, but it's not impossible. If advanced civilizations exist elsewhere in the galaxy, they might utilize interstellar corridors, natural pathways shaped by gravity and plasma flows, for communication or travel. It's conceivable that Voyager 1, by sheer luck, is passing through one of these channels and picking up fragments of transmissions not meant for us. Physicist Dr. Michio Kaku, while cautious about jumping to conclusions, has acknowledged that Voyager's recent findings hint at phenomena that lie beyond the limits of current scientific models. Whether it's new physics, evidence of dark matter, or even signs of extraterrestrial intelligence, he urges that we keep an open but rigorous mind. Back on Earth, NASA's Deep Space Network continues to monitor the faint whisper of signals coming from Voyager 1, traveling for over 20 hours at the speed of light just to reach us. Every byte of data is a miracle of endurance, a fragment of information from a place no human has ever seen. Yet, time is not on Voyager 1's side. Its power source, a radioisotope thermoelectric generator, is slowly losing its ability to generate electricity. NASA estimates that by the early 2030s, Voyager 1 may no longer be able to power its instruments or communicate at all. Even so, its legacy is secure. Voyager 1 has revolutionized our understanding of the solar system. Its data revealed that the heliopause, the boundary it crossed in 2012, is not static. It shifts and flexes, influenced both by solar activity and external forces from the galaxy beyond. This insight alone challenges long-held assumptions about the structure and behavior of our solar system's outer edge. In addition, Voyager's recordings of shockwaves from distant supernovae and its detection of interstellar magnetic fields are painting a clearer picture of how our Sun is embedded in a larger cosmic environment. These observations help us understand not just where we are, but how fragile and dynamic the space around us truly is. Voyager 1's findings are also informing future missions. Projects like Breakthrough Starshot aim to send tiny light-powered probes to nearby star systems at a fraction of light speed. These missions, inspired by Voyager's success, could one day follow in its path, collecting data from Proxima Centauri or other stars in our neighborhood. And just like Voyager, they may carry messages of who we are, a continuation of our search not just for knowledge but for connection. What Voyager 1 has done is more than just survive in deep space. It has redefined exploration. It has blurred the boundaries between science and philosophy, between observation and wonder. It asks us not only what lies beyond the stars, but also who we are as a species willing to reach for them. For now, Voyager 1 continues its silent voyage, traveling at over 38,000 miles per hour, drifting farther and farther into the void. One day, it will fall silent, its instruments too cold to function, its signal too weak to hear. But its journey will go on. For billions of years, it will coast between the stars, carrying the golden record, carrying our voices, our music, our stories. A fragile artifact of human hope adrift in the cosmos. It may never be found. But that's not the point. Voyager 1 represents the best of us, our curiosity, our courage, and our desire to understand what lies beyond the known. It proves that even the smallest machine, born of wires and will, can reach across unimaginable distances and touch the edges of forever. And in doing so, Voyager 1 reminds us of a powerful truth: the universe is vast. But we are not alone in it, not